February 19th, 1945. 0 hours. The volcanic black sand of Iwo Jima's beaches churned under the treads of a vehicle that would redefine the nature of close combat warfare. Marine Corporal Robert Dunlap, manning the turret of an M4A3R3 Sherman flamethrower tank designated Satan's Chariot, watched through his periscope as Japanese machine gun fire sparked harmlessly off his frontal armour. The bunker firing at his infantry was invisible, perfectly camouflaged in the volcanic rock 75 yards ahead. Standard doctrine called for infantry to assault with satchel charges and grenades, a process that typically cost a dozen Marine lives per position. But today, Dunlap had a different solution. He keyed his radio and spoke 4 words that would echo through the nightmares of Japanese defenders for the next month. Target bunker. Engaging flame. What emerged from the turret-mounted nozzle was not fire as soldiers had known it throughout history, but something far more terrible. A pressurized stream of napalm-thickened fuel ignited mid-flight, creating a jet of adhesive fire that reached temperatures of 2,000 degrees Fahrenheit. The flame lance shot forward 150 yards, far beyond any man-portable flamethrower's range, and struck the bunker's firing port with mechanical precision. For 3 seconds, Dunlap held the trigger. In that time, 120 gallons of burning gel poured into the fortification. The Japanese soldiers inside had no chance to scream. The temperature inside the confined space exceeded 500 degrees within 2 seconds. Lungs seared instantly, flesh ignited, ammunition cooked off in random sympathetic detonations. When the flames stopped, the bunker was silent. Smoke poured from every opening. The Marines advancing behind Satan's Chariot didn't take fire from that position. They never would again. 31 more bunkers would fall to flame tanks that first day. By the time the American flag was raised on Mount Suribachi 5 days later, the flamethrower tank had proven itself the most psychologically devastating weapon in the Pacific arsenal. The Japanese defenders, who had constructed the most sophisticated defensive network in military history, discovered that their impregnable fortifications had become death traps. This is the story of how American engineering transformed fire into a precision weapon system, how volcanic rock fortresses became crematoriums, and how the most fanatical defenders in modern warfare broke psychologically before a weapon that turned their greatest strength into their ultimate weakness. The flamethrower tank didn't win Iwo Jima alone, but without it the island might still be unconquered. The concept of armoured flamethrowers emerged from the horrific lessons of World War I, where man-portable flamethrowers, introduced by Germany in 1915, proved devastatingly effective but suicidally dangerous for their operators. The average life expectancy of a German Flammenwerfer operator in combat was measured in minutes. The massive fuel tanks on their backs made them priority targets, and a single bullet strike could transform the operator into a human torch. Yet the psychological and tactical effectiveness of flame weapons was undeniable. British experiments in the 1920s and 30s explored mounting flamethrowers on tanks, recognizing that armour could protect the operator and fuel supply while providing mobility. The Crocodile system, a towed trailer carrying 400 gallons of fuel connected to a Churchill tank, would eventually prove successful in European operations. But these systems were designed for the open terrain of Europe, not the confined volcanic hellscape that was Iwo Jima. The American flamethrower tank program began in earnest in 1943, driven by the bloody lessons of Pacific Island warfare. At Tarawa in November 1943, Marines discovered that standard naval bombardment, which had worked adequately against European fortifications, was almost useless against Japanese positions built into coral and reinforced concrete. Bunkers that had absorbed direct hits from 16-inch naval shells remained operational, their defenders emerging to massacre Marines on the beaches. Lieutenant Colonel Evans Carlson, who had led the Makin Island raid and witnessed Japanese defensive tactics firsthand, submitted a report to Marine Corps headquarters that was prophetic. The Japanese defensive doctrine prioritizes underground fortification connected by tunnels. Surface bombardment is largely ineffective. The only method to neutralize these positions is direct assault, which costs tremendous casualties, or the application of persistent incendiary effects that make the positions uninhabitable. We need mobile flame projection systems that can operate under fire and deliver sustained thermal effects into confined spaces. The Chemical Warfare Service, responsible for flamethrower development, had been working on various designs since 1942. The man-portable M1 and M2 flamethrowers used in the Pacific had ranges of only 20 to 40 yards and carried just 4 gallons of fuel, enough for 8 to 10 seconds of firing, effective but limited. The breakthrough came from an unlikely source. Navy researchers at the Chemical Warfare Service depot in Hawaii had been experimenting with thickened fuel agents to improve the performance of incendiary bombs. Napalm, a portmanteau of naphthenic and palmitic acids mixed with gasoline, created a gel that stuck to surfaces and burned with intense persistent heat. When this napalm mixture was pressurized through a projector system using nitrogen gas, the effective range tripled while the burning duration increased dramatically. The first production flamethrower tanks were expedient conversions. The M3 Stuart light tank, obsolete as a gun tank by 1944, was modified with the main gun removed and replaced with a flamethrower mechanism. Designated the M3 Satan, these tanks carried 150 gallons of thickened fuel and could project flame 80 to 100 yards. The system used compressed nitrogen at 300 psi to propel the fuel through an armoured tube and out a nozzle, where an ignition system, either electric or a series of small propellant cartridges, lit the stream. The Marines received their first Satan tanks in October 1944, and they saw limited action during the Saipan and Tinian campaigns. The results were promising but revealed significant limitations. The light armour of the Stuart made it vulnerable to Japanese anti-tank weapons. The fuel capacity was insufficient for sustained operations. Most critically, the flame gun replaced the main armament, leaving the tank defenceless after exhausting its fuel supply. Marine tankers reported that Japanese infantry, once they realised a tank was flame-armed and empty, would swarm it with magnetic mines and satchel charges. The solution was the POA-CWS-H1, a designation that stood for Pacific Ocean Area, Chemical Warfare Service, Hawaii, Model 1, but which Marines would simply call the Zippo or Ronson after popular cigarette lighters. The system was brilliantly simple. Take a standard M4A3 Sherman tank, remove the bow-mounted 75mm gun but retain the turret-mounted 75mm main gun, and install a flame projector in the bow gunner's position. The fuel tanks, holding 290 gallons of napalm mixture, were installed in the main hull, protected by the Sherman's armour. The nitrogen pressure tanks, charged to 350 psi, were mounted externally but armoured. The flame gun itself extended from the bow, looking deceptively like a machine gun barrel. But the crucial innovation was that the tank retained its main gun. After expending flame fuel, it could continue fighting as a conventional tank. This dual capability made it far more survivable than dedicated flame tanks. Captain Charles Roper, a Marine Corps tanker who would lead the flame tank platoon on Iwo Jima, trained with the new systems at Camp Pendleton in December 1944. His assessment was enthusiastic but realistic. The effective range is 150 yards in ideal conditions, about 120 yards in combat with wind and pressure variations. The fuel load gives us approximately 60 1-second bursts. That sounds like a lot, but in practice, you need 3 to 5 second bursts to effectively neutralize a bunker, so we're looking at 12 to 20 engagements per tank per mission. The flame is remarkably accurate. At 100 yards, you can put the stream through a firing port with practice. The psychological effect is immediate and total. We tested it against a bunker mock-up with volunteers inside wearing protective gear. Even though they knew it was a test and they were protected, several refused to remain in the structure when we fired. The heat is intense enough to be felt through 6 inches of concrete. The only significant weakness is fuel expenditure. Once you're empty, you're just another Sherman, but you've revealed yourself as a priority target. Japanese doctrine, we've learned from captured documents, specifically targets flame tanks. They know how effective they are. The decision to employ flame tanks on Iwo Jima was made at the highest levels of Marine Corps command. Intelligence estimates suggested the island's defenders had constructed an unprecedented defensive network. Aerial reconnaissance and submarine periscope observations revealed hundreds of bunkers, pillboxes and cave positions, all mutually supporting and connected by tunnels. The Japanese commander, Lieutenant General Tadamichi Kuribayashi, had abandoned the traditional Japanese doctrine of beach defense and counterattack. Instead, he created a defense in depth designed to inflict maximum casualties through prolonged attrition. Every position was reinforced concrete or carved into volcanic rock. Every bunker had multiple firing ports and at least 2 exits. Every strong point could support its neighbours with interlocking fields of fire. Kuribayashi's orders to his troops were explicit and chilling. "We shall fight to the death. Do not expect reinforcement. Do not expect evacuation. Our duty is to kill as many Americans as possible. The longer we resist, the more favourable the strategic situation becomes for the homeland. 100 days of resistance is our goal. Each day we survive costs the enemy resources and lives. Die with honour, but kill 10 Americans first." Against this defence, standard tactics would result in catastrophic casualties. The Marines requested every available flamethrower tank. By February 1945, 8 M4A3R3 Zippo tanks were assigned to support the invasion, divided among the assault divisions. It wasn't many, but it would prove sufficient to revolutionise the battle. The volcanic sand of Iwo Jima posed immediate problems. Navy Seabees, observing the beach composition during pre-invasion reconnaissance, reported that vehicles would struggle for traction. The sand wasn't the fine coral powder of other Pacific islands, but rather loose volcanic ash mixed with coarse black sand that offered almost no support. Wheeled vehicles would be immobilised immediately. Even tracked vehicles would struggle. The Sherman tanks, weighing 33 tons, sank 6 to 8 inches into the sand with every revolution of their tracks. Forward progress was measured in yards per minute rather than miles per hour. Fuel consumption tripled. Engine temperatures soared as the cooling systems choked on volcanic dust, but the tanks moved forward because the alternative was unthinkable. The initial assault waves of Marines, landing at 900 on February 19th, advanced 200 yards inland before Japanese fire began. Kuribayashi had held his fire during the landing, allowing the beaches to become packed with men and equipment. Then every weapon opened fire simultaneously. Marines described it as erupting into hell. Machine gun fire from dozens of carefully sighted positions swept the beaches in interlocking patterns. Mortars, pre-registered on every square yard of the landing zones, dropped with metronomic precision. Artillery, including massive 320 mm spigot mortars that fired 700-pound shells, turned the beach into a moonscape of craters and body parts. The Marines went to ground, digging frantically into the volcanic sand for any cover, but the sand was loose and unstable. It provided no protection, and worse, it was almost impossible to dig into. Shovels passed through it like water. Foxholes collapsed as fast as they were dug. Men lay in the open, pressing themselves into slight depressions, praying the next shell would land somewhere else. This was the situation when the first Sherman tanks landed 30 minutes after the initial assault. The ramps dropped, the tanks drove forward, and immediately several bogged down in the soft sand at the waterline. Combat engineers working under fire bulldozed paths through the beach terraces, creating somewhat more stable routes. The tanks churned forward, some towing others that had lost traction, all of them drawing immediate anti-tank fire. The Japanese had prepared well for American armour. At least 40 anti-tank gun positions covered the beaches, including 47 mm guns and deadly 75 mm weapons salvaged from wrecked aircraft. These guns were in reinforced positions with narrow firing slits that made them nearly impossible to spot. They held fire until tanks came within point-blank range, typically 50 yards or less, ensuring first-round hits. 5 Sherman tanks were knocked out in the first hour, burning wrecks that marked the high water line of the assault. It was against this withering fire that the first Zippo tank, designated C-32 and nicknamed Corpse Maker by its crew, reached the terrace line where the beach met the volcanic rock of the island's interior. Second Lieutenant Richard Tischler, commanding C-32, identified a bunker complex that was pouring machine gun fire into Marines pinned in the open. The bunker was built into the base of a cliff, reinforced concrete front with a volcanic rock roof several feet thick. Naval bombardment had scarred it but not penetrated. Infantry assaults had been repulsed 3 times with heavy casualties. Tischler manoeuvred his tank to a hull-down position, 120 yards from the bunker, using a wrecked landing vehicle as cover. Through his periscope he could see the bunker's main firing port, a horizontal slit perhaps 18 inches wide and 6 inches tall. In a conventional tank, engaging such a target would require multiple 75 mm rounds, hoping that one shell would enter the opening. The odds of success were minimal, but Tischler wasn't in a conventional tank. He ordered his flame operator, Corporal William Fredette, to engage. Fredette had trained for this moment for 3 months. He aligned his sight on the bunker aperture adjusted for a slight wind from the left, and pressed the trigger. The flame lance erupted from the bow of the tank. To observers, it looked like a solid bar of orange fire, 150 yards long and as thick as a man's waist. It struck the bunker opening with precision that seemed impossible. For 4 seconds, Fredette held the trigger. The napalm stream poured into the bunker at a rate of 30 gallons per second, 120 gallons total. The temperature inside the bunker reached levels incompatible with life within the first second. Anything combustible ignited. Steel glowed red. Concrete cracked and spooled from thermal shock. The 6 Japanese soldiers inside died before their nervous systems could register pain. The machine gun in the bunker cooked off, its ammunition detonating in a sustained roar. Secondary explosions suggested grenades or mortar rounds had been stored inside. When the flame shut off, the bunker was silent. Smoke and superheated air poured from every opening. The Marines who had been pinned down by that position began moving forward. They gave C-32 a wide berth, instinctively recognizing that being near a flame tank made you a target. But they also looked at the vehicle with something approaching reverence. That bunker had stopped their advance for 2 hours and cost them 11 dead and 23 wounded. The tank had neutralized it in 4 seconds. Word spread through the assault units with remarkable speed. The flame tanks work. Request flame support. Within an hour, every Marine company commander was calling for flame tanks to suppress positions that were holding up their advance. But there were only 8 tanks for an invasion front 3 miles wide. Priority went to the most critical positions, those that threatened entire battalions or blocked access to key terrain. The tactical employment of flame tanks evolved rapidly through brutal trial and error. Early attempts to use them like conventional tanks, moving forward with infantry and direct assault, resulted in immediate problems. The Japanese, recognizing flame tanks by their slightly different silhouette and the distinctive flame gun, concentrated all available anti-tank fire on them. 2 Zippos were damaged by anti-tank guns in the first afternoon, one severely enough to require evacuation. The solution was standoff engagement. The flame tanks would move to hull-down positions, use terrain for protection, and engage bunkers from maximum effective range. The 75 Flamethrower main gun would suppress any anti-tank positions that revealed themselves, while the flame gun handled the fortifications. Infantry would assault only after the position was neutralized, reducing casualties dramatically. By the evening of February 19th, the flame tanks had destroyed or neutralized over 40 fortified positions. The cost in American lives saved was incalculable. Positions that would have required squad or platoon-level assaults, costing dozens of casualties each, were eliminated with single flame bursts. Major General Harry Schmidt, commanding the invasion force, received reports from his division commanders that were unanimous. The flame tanks were the most effective weapon system in the assault. More were needed immediately, but there were no more. The 8 tanks on island represented the entire available inventory. They would have to be maintained, rearmed, and employed with careful economy. The fuel supply was particularly critical. Each tank carried enough napalm for approximately 1 hour of combat operations, but refueling required the tank to withdraw to the beach, where fuel bowsers, brought ashore under fire, would pump fresh napalm mixture into the tanks. The process took 30 to 45 minutes and was dangerous. Fuel bowsers were priority targets for Japanese artillery. 2 were destroyed by mortar fire on the first day, killing their crews and spreading burning napalm across the beach. The nitrogen pressure system required even more careful maintenance. Each tank carried 4 nitrogen bottles charged to 350 psi. As fuel was expelled, pressure dropped. Below 250 psi, effective range decreased significantly. Below 200 psi, the flame gun became nearly useless. The pressure bottles had to be swapped out regularly, a process that required specialized equipment and trained technicians. The Marine Corps had brought exactly 2 nitrogen charging units to Iwo Jima. If both were destroyed, the flame tanks would become conventional gun tanks. The Japanese response to flame tanks was immediate and sophisticated. Captured documents and prisoner interrogations reveal that Kurabayashi had issued specific orders regarding American flame weapons. The flamethrower tank is the most dangerous weapon the enemy possesses. It must be destroyed at all costs. Anti-tank guns will prioritize flame tanks above all other targets. Infantry will attempt to approach flame tanks with explosives when opportunity permits. If a flame tank is disabled, recovery crews must be engaged to prevent repair. The Americans have few of these weapons. Each one destroyed is a significant victory. Japanese infantry began specifically targeting flame tanks with satchel charges and magnetic mines. These attacks were suicidal, requiring a soldier to approach within yards of an armoured vehicle under fire, but Japanese doctrine accepted such sacrifices readily. On February 21st, Corporal James Day, later awarded the Medal of Honor for actions on Iwo Jima, witnessed such an attempt. We were supporting a flame tank C-25, I think, as it moved up to engage a cave position. Japanese soldier came out of a spider hole, we called them spider holes, right next to the tank's route. He had a satchel charge, maybe 20 pounds of explosives. He ran straight at the tank. We shot him, 5 or 6 of us hit him, but he kept coming on adrenaline or Bushido or whatever. Got within 10 feet before he went down. The charge went off. If he'd gotten 2 steps closer, he'd have disabled the tank. After that, we learned to check every foot of ground around flame tanks. The Japs were willing to die to kill them. The most effective Japanese counter to flame tanks was the carefully sighted anti-tank gun. These weapons, typically 47mm guns of excellent quality, were positioned in reinforced bunkers with firing ports that gave them fields of fire across likely tank approaches. The gunners had orders to hold fire until flame tanks presented themselves, then engage at close range where a hit was certain. On February 23rd, the day the flag was raised on Suribachi, flame tank C-17, nicknamed Satan's Little Helper, was engaged by a 47mm gun at a range of 65 yards while positioning to attack a bunker complex. The Japanese gunner, displaying remarkable fire discipline, had allowed 6 conventional Sherman tanks to pass without engaging. He was waiting for the Zippo. His first round struck C-17's bow armour at a near perpendicular angle, the ideal angle for penetration. The armour-piercing round punched through, but by fortune or providence, it missed the fuel tanks by inches. It severed the flame gun's fuel line, spraying napalm into the crew compartment, but did not ignite. The tank's driver, Private First Class Andrew Garcia, executed an immediate reversal, backing the tank into a crater while the crew frantically worked to seal the fuel leak. The Japanese gunner fired twice more, both rounds hitting the retreating tank but failing to penetrate the thicker side armour at the acute angles. Garcia got the tank into cover, the crew evacuated through the belly hatch, and combat engineers subsequently recovered the vehicle. It was repaired and returned to service 4 days later. But the incident drove home the vulnerability of flame tanks to well-placed anti-tank weapons. The Marines adapted with combined arms tactics that became doctrine. Flame tank operations required infantry support to suppress enemy infantry, conventional gun tanks to destroy anti-tank positions, and combat engineers to mark safe routes through minefields. A typical flame tank mission by the battle's second week involved elaborate coordination. First, aerial reconnaissance and ground observers would identify a target bunker complex. Then conventional tanks would move forward and engage any visible anti-tank positions with high explosive and white phosphorus rounds. Artillery would drop smoke to obscure the flame tank's approach. Infantry would advance in coordination, ready to suppress any infantry threats. Finally, the flame tank would move to its engagement position, deliver flame, and immediately withdraw before Japanese artillery could bracket the position. This process was time-consuming and resource-intensive, but it worked. Casualties among flame tank crews remained remarkably low. In 36 days of combat on Iwo Jima, the 8 flame tanks conducted over 600 engagements against fortified positions. Only 1 crew member was killed, struck by a sniper bullet that penetrated a vision port. The tanks themselves were hit numerous times, accumulating damage that would have destroyed lesser vehicles, but Marine maintenance crews kept them operational through creative repairs and cannibalization. By the battle's end, some flame tanks were running on parts from 3 different vehicles. The psychological effect of flame weapons on the Japanese defenders was profound and unexpected. Kuribayashi's troops were among the most disciplined and fanatical in the Imperial Japanese Army. They had been indoctrinated to fight to the death, to embrace death with honor rather than surrender. Suicide attacks were routine. Wounded soldiers would often detonate grenades rather than accept medical treatment. These were not men easily frightened, yet the flame tanks broke them. The first evidence came from prisoner interrogations. The Marines took very few prisoners on Iwo Jima, typically less than 1% of the defending force, but those captured were debriefed extensively. A Japanese private, Ito Shigeru, captured on March 3rd after being trapped in a collapsed cave, provided testimony that was circulated throughout Marine intelligence. The flame tanks were our greatest terror. We could endure the naval bombardment. We could survive the artillery. We had prepared for the infantry assaults, but the fire weapons there was no defence. Our strongest bunkers became ovens. Comrades would burn alive and we could do nothing. The sound of the flame tank's engines, you could hear them coming, made men vomit with fear. Some soldiers killed themselves rather than face capture by fire. I saw a sergeant cut his throat with his bayonet when he heard a flame tank approaching. He said burning was the worst death, that it destroyed the body so completely that the spirit could not rest. Better to die by his own hand. I surrendered because I was buried and had no weapon to kill myself. I am shamed by my survival, but I could not face the fire again. Other prisoners reported similar psychological degradation. The Japanese doctrine of defense in depth meant that soldiers would watch from connected positions as their comrades were burned out. They saw the effect of flame weapons repeatedly, building anticipatory dread. By the battle's third week, some Japanese soldiers were abandoning positions when flame tanks approached, fleeing deeper into the defensive network rather than face incineration. This was unprecedented behaviour for Japanese troops and suggested complete psychological collapse in the face of fire. The physiological effects of flame weapons in confined spaces contributed to this terror. When napalm burns in an enclosed space, it consumes oxygen at an extraordinary rate. A 3-second flame burst into a typical bunker, perhaps 200 cubic feet in volume, would consume all available oxygen within seconds. Defenders who were not directly burned would suffocate. But the process wasn't instantaneous. They would experience seconds of oxygen deprivation, during which they would feel themselves suffocating while simultaneously being exposed to radiant heat that blistered exposed skin. Those who survived the initial flame burst, perhaps in a deeper chamber or behind a turn in the tunnel, would experience the aftermath. The air temperature throughout the structure would exceed 150 degrees Fahrenheit. Smoke, a mixture of burning napalm, ignited materials and human tissue, would be toxic and blinding. Carbon monoxide levels would be immediately lethal. Attempting to breathe would sear lung tissue. The few who survived even minutes in such conditions typically suffered permanent respiratory damage and psychological trauma so severe they were unable to function. Marine Corps physicians documented several cases of Japanese soldiers who emerged from flame-attacked positions alive but catatonic. These men, even after evacuation to hospital ships and medical treatment, remained unresponsive. They would not speak, would not eat voluntarily, and showed no reaction to external stimuli. Modern diagnosis would likely classify their condition as severe psychological trauma with dissociative features, but in 1945 it was simply noted as battle fatigue, severe. The effectiveness of flame tanks varied based on the target type. Against standard reinforced concrete bunkers with limited openings, flame was devastatingly effective. The napalm stream could be directed through firing ports with precision, and the confined space ensured rapid oxygen consumption and temperature increase. Kill probability approached 100%. Against cave positions with multiple chambers and complex tunnel networks, flame was less uniformly effective. The initial chambers would be cleared, but deeper positions might survive if they had sufficient depth and indirect access. These required multiple flame attacks from different angles or follow-up with demolitions and grenades by infantry. Against open emplacements or positions with large openings, flame was less effective. The napalm would burn intensely but briefly, and defenders could sometimes escape through rear exits. These positions were better engaged with high explosive rounds from the 75mm gun. The Marines developed a tactical decision matrix for flame employment. Small bunkers with single openings use flame. Large bunkers with multiple openings use flame followed by infantry assault. Cave systems use flame for initial chambers then demolitions. Open positions use high explosive. Tank crews became expert at reading the terrain and structures to determine optimal engagement methods. The battle for Hill 382, a volcanic ridge in Iwo Jima's northern sector that American forces called the meat grinder, demonstrated flame tanks at their most effective. The hill was honeycombed with tunnels and bunkers, all mutually supporting. Japanese defenders could move through the tunnel network, appearing in different positions to engage attacking Marines, then disappearing, before counterfire could be brought to bear. Conventional tactics had failed for 4 days. Casualties were staggering, with some companies reduced to 40% strength. On February 28th, 4 flame tanks were assigned to support the assault on Hill 382. The plan was methodical. Rather than attempting to storm the hill, the Marines would systematically destroy every visible opening. The flame tanks, supported by conventional tanks and infantry, would move from position to position, delivering flame into each bunker, cave mouth, and fighting position. After flaming, combat engineers would seal the openings with demolitions, ensuring that any survivors could not re-emerge. The operation took 6 hours. The 4 flame tanks expended their entire fuel loads 3 times each, requiring multiple returns to the beach for refueling. They engaged over 70 separate positions. The violence was mechanical and total. Flame would pour into an opening for 5 to 10 seconds, far longer than usual, ensuring complete saturation of the interior spaces. Then high explosive rounds would collapse the entrance, move to the next position, repeat. By evening, Hill 382 was silent. The tunnel network had become a tomb for over 300 Japanese defenders. Not a single Marine was killed in the assault. The psychological impact on surviving Japanese forces elsewhere on the island was significant. They had watched the systematic destruction of what was considered their strongest position. Kurabayashi's staff officers reported that soldiers throughout the defensive network were demoralized by the loss of Hill 382. If the strongest position could be reduced to a crematorium, nowhere was safe. The final phase of the Iwo Jima battle, from mid-March until the island was declared secure on March 26th, devolved into what Marines called blowtorch and corkscrew operations. Small units with flame weapons, demolitions, and grenades would systematically clear the remaining cave systems and bunkers. The flame tanks, by this point in the battle, were operating despite extraordinary accumulated damage. Technical inspection reports from late March documented the conditions. One tank had taken 47 hits from small arms and anti-tank weapons. Another had been partially buried by artillery. A third had suffered an engine fire that melted wiring and damaged seals. Yet all remained operational through what Marines called Ordnance Department miracles and mechanical profanity. Sergeant William Sayers, a tank mechanic with the 4th Tank Battalion, described the maintenance challenge. These flame tanks were shot to hell. Armour had spalls, cracks, holes. The flame guns were bent from near misses. The fuel systems were held together with baling wire and hope. We worked on them at night under blackout tarps because the Japs still had artillery. I replaced a final drive assembly under mortar fire once, but we kept them running. Every time a tank went down, we'd cannibalize parts from damaged vehicles, fabricate replacements from scrap, do whatever it took. The infantry was counting on these tanks. We heard the stories about bunkers being cleared in minutes instead of hours. We knew every hour we got a flame tank back in service was saving Marine lives. I once worked 26 hours straight to get a tank operational for an assault the next morning. When it rolled out and I heard it had destroyed 14 bunkers without a single Marine killed, that was worth every minute. The final statistics of flame tank operations on Iwo Jima were documented in after-action reports. 8 M4A 3R3 flame tanks conducted approximately 650 separate flame engagements. They destroyed or neutralized an estimated 600 to 800 fortified positions. They consumed roughly 40,000 gallons of napalm mixture. They fired approximately 100 to 200 rounds of 75 km ammunition in their secondary gun tank role. 1 crew member was killed. 3 tanks were damaged severely enough to require major repairs. 5 returned to service with battle damage but remained operational. The cost savings in Marine lives was estimated at between 1,500 and 2,000 casualties avoided. Every bunker destroyed by flame tank was a bunker that didn't require a squad-level assault. Every cave sealed by flame was a position that didn't have to be cleared by infantry with grenades and satchel charges. The mathematics were brutal but clear. Each flame tank saved hundreds of Marine lives. Major General Graves Erskine, commanding the 3rd Marine Division, submitted a recommendation that every Marine Division include an organic flame tank company. The flamethrower tank has proven itself the single most effective weapon against fortified positions in the Pacific War. Its psychological effect on the enemy equals its material effect. Japanese prisoners report that flame weapons were feared above all others. The expenditure of resources to produce and maintain these vehicles is more than justified by the reduction in casualties and increase in operational tempo. Future operations against the Japanese home islands will require extensive use of flame tanks. I recommend immediate expansion of production and assignment of flame tank battalions at corps level. The Japanese perspective on flame weapons was documented in captured orders and post-war interrogations. Lieutenant Colonel Takeichi Nishi, commanding the 26th Tank Regiment on Iwo Jima, wrote in his final message sent by radio to Tokyo before his death on March 22nd, "The enemy's fire weapons have broken our strongest defences. Positions that could withstand naval bombardment and aerial bombs are defeated by flame tanks. The Americans have learned to attack systematically with these weapons. Our casualties from flame are catastrophic. The men face this weapon with despair. No defence is effective. When the flame enters a position, all inside perish. The survivors throughout the defensive network are aware of their inevitable fate. Morale is destroyed. I regret that I cannot find a way to counter this weapon. My regiment will fight to the end, but I report honestly that our position is hopeless in the face of American flamethrower technology." General Kurebayashi, in his final communication before his death during a last-ditch attack on March 26th, was equally blunt about the impact of flame weapons. "The American use of flame tanks has negated our defensive preparations. Our strongest bunkers, built to withstand anything in the American arsenal, are defeated in seconds. The psychological impact on the troops is severe. Many positions have been abandoned when flame tanks approach. This is contrary to all our doctrine and training, but the men cannot overcome their fear of burning. I have failed to develop tactics to counter this weapon effectively. The Americans have achieved total tactical surprise with a weapon we did not adequately prepare for. Future defences must account for flame weapons, though I cannot conceive of a defence that would be effective. The only counter is to destroy the flame tanks before they deploy, which requires anti-tank weapons and gunners willing to sacrifice themselves. We have lost most of our anti-tank capability. The situation is desperate." The broader implications of flamethrower tank operations on Iwo Jima influenced American planning for the invasion of Japan itself. Operation Downfall, the planned two-phase invasion of the Japanese home islands, scheduled to begin in November 1945, included provisions for massive flame tank deployments. The operational plans called for 600 flamethrower tanks to support the initial assault on Kyushu, with an additional 1,200 to be produced for the second phase against Honshu. The anticipated Japanese defensive preparations for the home islands included extensive fortification systems, with estimates suggesting over 50,000 bunkers, cave positions, and fighting positions throughout the target areas. Based on Iwo Jima experience, planners calculated that systematic reduction of these fortifications without flame weapons would cost between 500,000 and 1 million American casualties. With flame tanks, casualties were projected to be reduced by 40 to 60%. These projections directly influenced the decision to use atomic weapons. President Harry Truman, in his post-war memoirs, cited casualty estimates for the invasion of Japan as a primary factor in authorizing the atomic bombings. While historians continue to debate this justification, the operational plans clearly show that military planners anticipated horrific losses in any ground invasion, mitigated significantly, but not eliminated by flame weapons. The atomic bombs made the invasion unnecessary, but the flamethrower tanks had proven that even the most fanatical defenders could be defeated given sufficient technological superiority and industrial capacity. The legacy of flamethrower tanks extended beyond World War II. The US military continued to develop and deploy flame tanks through the Korean War and into the Vietnam era. The M67 flamethrower tank, based on the M48 Patton chassis, served in Vietnam where it proved effective against bunker complexes and tunnel systems. Modern thermobaric weapons, which create a pressure wave and consume oxygen in enclosed spaces, are direct descendants of flame weapon technology. The basic tactical problem, how to neutralize defenders in fortified positions without suffering prohibitive casualties, remains relevant in contemporary asymmetric warfare. But it was on Iwo Jima that the flamethrower tank proved its essential nature. The volcanic island, transformed into a fortress by Japanese engineering, was reduced to a graveyard by American technology. The transformation of fortifications into crematoriums was systematic, mechanical, and ultimately decisive. The Japanese defenders, who had prepared to fight to the death and inflict maximum casualties, discovered that their greatest defensive advantages, the bunkers and caves that made them immune to conventional weapons, had become liabilities. Corporal Robert Dunlop, whose tank Satan's Chariot survived the battle with over 30 hits from various weapons, later reflected on the campaign. "We weren't heroes, we were mechanics operating a machine that was purpose-built to kill in the most horrific way imaginable. Every time I pressed that trigger and watched the flame reach out, I knew I was incinerating human beings. They were enemy soldiers trying to kill my fellow Marines, so I did my job without hesitation. But I never forgot what we were doing. The flame tank turned war into industrial slaughter. Efficient, mechanical, absolute. The Japs in those bunkers didn't have a chance once we got our gun on target. I take no pride in that, but I don't apologize for it either. My job was to keep Marines alive. Every bunker I burned out was a bunker that wouldn't kill my friends. The mathematics was simple. We had the better weapon. They died. We lived. That's war reduced to its essential nature. 8 tanks, 36 days, 600 fortifications destroyed. The flamethrower tanks didn't win Iwo Jima alone. The victory required the courage of Marines who crossed the beaches under fire, the skill of naval gunners who provided support, the determination of artillery crews who fired until their barrels were worn smooth. But the flame tanks provided the decisive edge that transformed an impregnable fortress into a conquerable objective. When the American flag was raised on Mount Suribachi on February 23rd, 5 days into the battle, flame tanks had already destroyed over 200 Japanese positions. By the time the island was declared secure on March 26th, the volcanic rock had been scoured clean of organised resistance. The bunkers remained, scarred and blackened, monuments to the defensive preparations that had promised an impregnable fortress. Inside those bunkers, the evidence of flame weapons remained for decades. Blackened walls, melted steel. Fused volcanic rock where temperatures had exceeded stone's melting point, and silence. The flamethrower tank transformed Iwo Jima's bunkers into graves with mechanical efficiency. The defenders who had mocked the idea of defeat learned that technology, properly applied, defeats courage. The Marines who faced those defences learned that superior weapons save lives. And military historians learned that the most terrifying weapon isn't the one that kills the most efficiently, but the one that destroys the enemy's will to resist. The flame did both. The technical evolution of flame weapons between Iwo Jima and subsequent operations revealed the rapid pace of American military innovation under combat conditions. The M4A3R3 Zippo tanks, despite their success, suffered from limitations that became apparent only through sustained combat use. The primary issue was fuel capacity versus engagement duration. While 290 gallons seemed substantial, combat operations revealed that effective bunker neutralization required significantly more fuel than peacetime testing had suggested. In testing against mock-up bunkers at Camp Pendleton, engineers had calculated that a 3-second burst would neutralize a standard fortification. This calculation proved optimistic. Real Japanese bunkers on Iwo Jima featured multiple chambers, connecting tunnels, and internal structures that created dead spaces where flame didn't penetrate. Effective neutralization required 5 to 10-second bursts, sometimes multiple bursts into different openings of the same complex. This meant that instead of 60 theoretical engagements per fuel load, combat reality provided 12 to 20 effective engagements. Tank commanders learned to ration their fuel carefully, prioritizing targets that posed the greatest threat to advancing infantry. Technical Sergeant Harold Morehouse, a flame tank commander with the 5th Tank Battalion, described the tactical calculations. You're sitting there with 290 gallons of napalm and you've got 30 bunkers in front of you. Infantry's calling for support on all of them. You have to decide which ones get flame and which ones get bypassed or handled with conventional weapons. We prioritized based on fields of fire. A bunker that could enfilade our advance got flame immediately. A bunker covering a less critical approach might get marked for infantry to handle or for a second pass after refueling. You had to think like a miser with your fuel because once you were empty, you were done for that mission. The refueling process meant withdrawing to the beach, waiting for a fuel bowser that was probably under artillery fire, pumping 290 gallons, which took 30 to 40 minutes, then driving back to the front. That's 2 hours minimum out of action. In 2 hours, how many Marines might die assaulting bunkers that we could have flamed? That calculation haunted us. The fuel mixture itself evolved during the Iwo Jima campaign. The standard napalm formula, gasoline thickened with aluminum naphthenate and aluminum palmitate, burned at approximately 1800 to 2000 degrees Fahrenheit. Chemical warfare service technicians on Iwo Jima experimented with additives to increase temperature and burning duration. Magnesium powder, added at a ratio of 5% by weight, increased combustion temperature to over 2200 degrees. White phosphorus, mixed at 2%, provided a secondary incendiary effect that continued burning even after the primary fuel was consumed. These enhanced mixtures proved more effective against reinforced concrete, which required higher temperatures to cause structural spalling and failure. The downside was increased wear on the flame gun components and higher risk of premature ignition. Several incidents occurred where the enhanced mixture self-ignited in the fuel tanks due to static electricity or friction heat. One flame tank, C-29, suffered a fuel fire on March 8th while refueling. The enhanced napalm mixture ignited in the transfer hose, spreading fire to both the tank and the fuel bowser. 3 crewmen suffered severe burns, and the tank was destroyed. After this incident, the enhanced mixture was reserved for specific high-priority targets where the additional effectiveness justified the increased risk. The ignition systems on flame tanks proved remarkably reliable, despite harsh conditions. The primary ignition method used a series of pyrotechnic cartridges, essentially large blank rounds, that fired through ports near the flame gun nozzle. These cartridges created a shower of sparks and burning particles that ignited the fuel stream as it emerged. Each flame tank carried 200 ignition cartridges, theoretically enough for 200 separate flame bursts. In practice, crews learned to economize by using one cartridge for multiple bursts if they were firing in rapid succession, since residual burning fuel at the nozzle would ignite subsequent streams. The backup ignition system used an electrical arc, similar to a spark plug, but this system proved less reliable in the volcanic dust environment of Iwo Jima. The fine particles infiltrated electrical connections, causing short circuits and misfires. Maintenance crews spent considerable time cleaning and replacing ignition components. By the battle's end, most flame tanks were operating solely on pyrotechnic ignition, having abandoned the electrical systems as too unreliable. The armor protection of Sherman-based flame tanks provided adequate defense against most Japanese anti-tank weapons, but several engagements revealed vulnerabilities. The standard M4A3 had frontal armor ranging from 2 to 3 inches depending on location. This was sufficient to defeat Japanese 37 Lia-Swatons and 47 Lia-Mnia anti-tank guns at ranges beyond 500 yards, but at close range, particularly under 200 yards, penetration was possible. The Japanese 75mm anti-tank guns, fewer in number but positioned at key defensive points, could penetrate Sherman frontal armor at ranges up to 1,000 yards. The flame fuel tanks, positioned in the main hull, were theoretically protected by this armor, but a penetrating hit that reached the fuel would have catastrophic consequences. Fortunately for the crews, this scenario never materialized on Iwo Jima. The several flame tanks that were penetrated by anti-tank fire were hit in locations that missed the fuel tanks. The most dangerous moment for any flame tank was during the actual flame discharge. The flame stream, visible for hundreds of yards and creating a distinctive visual signature, marked the tank's position unmistakably. Japanese artillery observers would call fire on flame tanks immediately upon seeing them discharge. The standard Japanese procedure was to fire white phosphorus marker rounds, followed by high explosive saturation of the target area. Flame tank commanders learned to fire from defilade positions when possible, and to displace immediately after each engagement. The tactic was shoot and scoot. Flame the target, then reverse into cover before counter-battery fire arrived. Lieutenant Donald Kaufman, commanding flame tank C-24, described a near miss from counter-battery fire. We'd just flamed a cave complex on the west coast, 3 bursts to make sure we got the deep chambers. I ordered reverse immediately and my driver had us backing into a crater within 5 seconds. Good thing, because Japanese 150mm rounds started dropping exactly where we'd been. 6 rounds, probably from a gun position we couldn't even see. They had pre-plotted firing coordinates for every spot a tank could shoot from. If we'd lingered even 10 seconds, we'd have been destroyed. The concussion from the nearest round, maybe 40 yards away, still rattled us pretty good. Instruments shattered, Our radio antenna was blown off, and my driver got a bloody nose from his face hitting the periscope, but we survived. After that, we never stayed in one place more than 5 seconds after firing. The combined arms doctrine that evolved on Iwo Jima became the template for flame tank employment in subsequent campaigns. The Marine Corps formalised these tactics in a field manual published in July 1945 titled Tactical Employment of Flamethrower Tanks in Reducing Fortified Positions. The manual codified lessons learned through blood and experience. Key principles included never operate flame tanks without infantry security, never engage without reconnaissance of approach routes, never remain stationary after firing, always have conventional gun tanks in overwatch, always coordinate with artillery for suppression and smoke, and never attempt to flame a position that had clear fields of fire against the tank's approach. The manual included detailed diagrams showing optimal engagement angles, recommended distances for various target types, and fuel consumption planning tables. It became required reading for all Marine tank officers and was distributed to Army armoured units preparing for the invasion of Japan. The psychological operations aspect of flame weapons received official recognition following Iwo Jima. Intelligence officers analysing prisoner interrogations and captured documents noted that Japanese defensive plans for the home islands specifically addressed flame weapons as a critical threat. Defensive fortifications were being redesigned with flame attacks in mind, including features like multiple 90-degree turns in tunnel systems to prevent flame penetration, improved ventilation systems to exhaust smoke and heat, sealed doors to contain flame-to-entry chambers, and elevated firing ports positioned above the maximum elevation angle of tank-mounted flame guns. These adaptations suggested that the Japanese military, despite its reputation for inflexibility, was capable of learning and adapting. The American response was to develop improved flame systems with greater range, higher fuel capacity, and the ability to engage elevated targets. The T-33 flame gun, in development by August 1945, featured a longer barrel and higher pressure system that extended effective range to 200 yards and could elevate to 45 degrees, allowing engagement of positions on hillsides and cliffs. This system never saw combat due to the war's end, but it represented the ongoing arms race between defensive fortification and offensive flame technology. The environmental impact of massive flame weapon employment was never a consideration during World War II, but post-war studies documented the effects. Iwo Jima's volcanic soil, already relatively barren, was rendered completely sterile in areas of heavy flame tank activity. The extreme temperatures destroyed all organic matter in the soil and altered the chemical composition of the volcanic rock itself. Areas that received multiple flame attacks showed evidence of surface vitrification, where the rock had partially melted and reformed into a glass-like substance. The American cemetery on Iwo Jima, established after the battle, required soil to be imported from elsewhere on the island, because the ground at the original cemetery site had been so thoroughly incinerated that nothing would grow in it. The long-term health effects on flame tank crews were not studied systematically until decades after the war. Veterans of flame tank operations reported higher rates of respiratory problems, likely due to exposure to napalm fumes and combustion byproducts. The crews operated in enclosed spaces where ventilation systems drew in air from outside the tank, including during flame operations when the surrounding air was contaminated with partially combusted fuel vapours. Several crew members developed chemical sensitivity conditions that modern medicine would recognise as toxic exposure syndromes. The Veterans Administration eventually recognised these conditions as service-connected disabilities, but not until the 1980s, nearly 40 years after the exposures occurred. The evolution of flame tank tactics influenced broader doctrinal thinking about combined arms warfare. The success of flame tanks on Iwo Jima demonstrated that specialised weapon systems, properly employed within a combined arms framework, could solve tactical problems that conventional weapons could not. This principle influenced post-war American military doctrine, leading to the development of specialised weapons for specific tactical scenarios. The proliferation of specialised vehicles in the American military, from mine-clearing tanks to bridge-laying tanks to recovery vehicles, can be traced conceptually to the flame tank's success in proving that purpose-built systems justified their logistical overhead through tactical effectiveness. The individual stories of flame tank crewmen reveal the human dimension of operating these weapons. Staff Sergeant Ray Thomas, a flame operator with the 4th Tank Battalion, kept a diary throughout the Iwo Jima campaign. His entries provide insight into the psychological burden of flame warfare. February 24th. Burned out 6 bunkers today. Each time I press the trigger, I think about the men inside. They're burning alive because of me. I know they're enemy soldiers. I know they'd kill every Marine on this island if they could. But I can't stop imagining what it feels like to burn to death. Do they die instantly, or do they suffer? I asked the chaplain about this. He said I'm doing my duty, saving American lives, and that God understands the necessity of war. I want to believe that. But at night, I dream about flames. February 27th. Infantry told us we saved their lives today. They'd been pinned down by a bunker complex for 3 hours. 2 squads had tried to assault it, lost a dozen men. We flamed it in 30 seconds. The company commander shook my hand and said I was a hero. I don't feel like a hero. I feel like an executioner. But I'll keep doing it because the alternative is watching Marines die. March 3rd, saw a Japanese soldier run out of a cave we'd just flamed. He was on fire, completely engulfed. He ran maybe 20 yards before collapsing. Nobody shot him. We just watched him burn. I vomited after. Can't get the image out of my head. The chaplain says I should think of him as the enemy, not as a human being. But he was human. He ran from the fire just like I would. He died in agony just like I would. I pressed the trigger that killed him. How do I live with that? March 15th. We've burned out over 100 positions. I've stopped counting. I've stopped thinking about it too much. You can't function if you dwell on what you're doing. The other guys in the crew don't talk about it either. We do our job, we maintain the equipment, we go back to the lines the next day. That's all there is to it. The infantry keeps thanking us. That helps. Knowing that Marines are alive because of what we do, that makes it bearable. March 25th. The island is almost secured. Our tank is shot to pieces but still running. I'll be glad to leave this place. I'll be glad to never fire a flame gun again, but I know I'll never forget what I did here. Every man I burned, every bunker I turned into an oven, that's on my soul forever. I did it for my country and my fellow Marines. I'd do it again if ordered, but I hope to God I never have to. The industrial logistics supporting flame tank operations on Iwo Jima were staggering in scale and complexity. The napalm mixture had to be manufactured, transported across thousands of miles of ocean, and stored under combat conditions. The primary napalm production facility for the Pacific Theater was located at Port Chicago, California. The facility produced approximately 10 million gallons of napalm mixture annually by 1945, much of it destined for flame tanks and aerial incendiary bombs. The mixture was shipped to forward areas in 55-gallon drums, with each flame tank requiring approximately 6 drums per combat day, accounting for combat consumption and wastage. For the 8 flame tanks on Iwo Jima, operating over 36 days, the total napalm consumption approached 40,000 gallons, or approximately 730 drums. These drums had to be landed on hostile beaches under fire, transported to forward fuel points, and then pumped into tanks using specialized equipment. The fuel bowsers used for refueling were standard tank trucks modified with pumps capable of handling the viscous napalm mixture. These vehicles, typically crewed by 2 men, were among the most dangerous positions on the island. They were soft-skinned, meaning no armor protection, carrying hundreds of gallons of highly flammable fuel, and had to operate in forward areas within range of Japanese artillery. The crews volunteered for this duty knowing the risks. 5 fuel bowser crewmen were killed during the Iwo Jima campaign, 4 by artillery fire and 1 by a sniper. Their vehicles were priority targets for Japanese observers who understood that destroying fuel supplies would neutralize the flame tanks more effectively than trying to destroy the heavily armored tanks themselves. The nitrogen pressure system presented its own logistical challenge. Each flame tank required 4 nitrogen bottles, each containing 200 cubic feet of nitrogen compressed to 350 psi. These bottles had to be recharged after every full fuel load was expended. The recharging equipment consisted of a compressor unit, a nitrogen generator using chemical reaction, and high-pressure storage tanks. 2 such units were brought to Iwo Jima, both operating continuously throughout the battle. The process of recharging a set of bottles took approximately 2 hours, creating a bottleneck in flame tank operations. By the battle's 3rd week, the Marine Corps flew in additional nitrogen generation equipment from Guam, increasing capacity to meet operational demands. The training pipeline for flame tank crews was condensed and intense. Standard tank crewman training took approximately 16 weeks. Flame tank specialists received an additional 4 weeks of training at the Chemical Warfare Service School at Edgewood Arsenal, Maryland, or at the Marine Corps Flame School at Camp Pendleton, California. The curriculum included flame gun operation and maintenance, napalm properties and handling, pressure system operation, tactical employment of flame weapons, recognition of target types and appropriate engagement methods, safety procedures and emergency protocols, and coordination with infantry and conventional armour. The washout rate from Flame School was approximately 30%, higher than conventional tank training. The primary causes of failure were psychological unsuitability, inability to operate complex flame systems under stress, and safety violations during training. The Marine Corps psychologists, a relatively new specialty in World War II, conducted screening interviews with flame tank candidates. They looked for specific personality traits including emotional stability under stress, ability to compartmentalize, following orders without hesitation, mechanical aptitude, and what one screening document termed acceptance of mission requirements without moral reservation. This last criterion was controversial even then. Some psychologists argued that men who could burn other human beings without moral qualms were potentially sociopathic and might pose risks after the war. Others contended that men who understood the moral weight of their actions but could perform them anyway out of duty were actually more stable and reliable. The debate was never resolved, but the screening continued. Post-war studies of flame tank veterans showed no elevated rates of criminal behaviour or social maladjustment compared to other combat veterans, suggesting that the screening process was effective or that concerns about psychological damage were overstated. However, flame tank veterans did report higher rates of combat-related nightmares and intrusive thoughts decades after the war, suggesting lasting psychological impact. The Japanese tactical response to flame tanks evolved throughout the battle, demonstrating that even in a hopeless strategic situation, tactical adaptation continued. Early in the battle, Japanese defenders would remain in their bunkers during flame attacks, trusting their fortifications to protect them. This proved fatal in almost every case. By the battle's second week, captured documents and prisoner reports indicated that Japanese commanders were ordering troops to evacuate positions through rear exits when flame tanks approached, then reoccupy after the tanks moved on. This tactic had some success, but it required split-second timing and often resulted in troops being caught in the open by accompanying infantry. The Marines adapted by coordinating flame attacks with infantry overwatch. As the flame tank engaged the front of a position, infantry covered the rear exits. Japanese soldiers fleeing the flames would emerge directly into rifle fire. This created an impossible dilemma for defenders: remain inside and burn or flee and be shot. Some Japanese commanders ordered their troops to remain in positions regardless of flame attacks, accepting total casualties as preferable to piecemeal destruction. These orders reflected the fatalistic desperation of the Japanese defensive strategy by late March. Other commanders authorized their troops to conduct counterattacks against flame tanks, accepting suicidal tactics as the only available response. These banzai charges against armoured vehicles were as unsuccessful as they sound. Japanese infantry armed with rifles, grenades and satchel charges, charging across open ground against tanks supported by infantry and conventional armour, resulted in predictable massacres. Yet the attacks continued because no other option existed. General Kurabayashi, in his final dispatches to Tokyo, acknowledged that effective tactics against flame tanks required weapons and capabilities his forces no longer possessed. To defeat the flame tanks, we require anti-tank guns in sufficient quantity to ensure hits, artillery with capability to conduct rapid counter-battery fire, and air support to strike enemy armour in their assembly areas. We possess none of these. Our anti-tank guns have been destroyed or are ineffective at the ranges where flame tanks engage. Our artillery is suppressed by overwhelming enemy firepower. Our air support is non-existent. Therefore, we have no tactical solution. We can only endure and inflict what casualties we can before inevitable defeat. The medical treatment of burn casualties from flame attacks presented unique challenges for both American and Japanese medical personnel. The few Japanese soldiers who survived flame attacks and received medical treatment suffered burns that were universally severe. Napalm, unlike conventional fire, sticks to skin and continues burning until the fuel is consumed or oxygen is denied. The burns were typically third degree, destroying all layers of skin and often underlying muscle and tissue. The few Japanese prisoners who survived such injuries, typically because they were in peripheral areas of flame attacks and received immediate buddy aid, required months of treatment and suffered permanent disfigurement. American medical personnel treating these casualties noted that the psychological trauma often exceeded the physical injuries. Patients would become agitated at any sudden sound or movement, particularly anything resembling engine noise. Several became violent when medical personnel attempted treatment, fighting with surprising strength despite severe injuries. Modern understanding of trauma psychology recognizes these as symptoms of severe PTSD combined with pain-induced delirium, but in 1945 they were simply noted as combative patients requiring restraint. The ethical questions surrounding flame weapons were raised even during the war, though not prominently. Some medical officers and chaplains questioned whether weapons that caused such horrific injuries were consistent with the laws of war and basic humanity. The Geneva Conventions existing at the time did not specifically address flame weapons, though they did prohibit weapons calculated to cause unnecessary suffering. The US military's position was that flame weapons were legitimate tools for reducing fortifications, and that any suffering they caused was a regrettable but acceptable consequence of military necessity. This position was never seriously challenged during World War II, when the overriding priority was winning the war as quickly as possible, with minimum American casualties. The debate would resurface during Vietnam, when images of flame attacks broadcast on television prompted public outcry and contributed to anti-war sentiment. The final accounting of flame tank effectiveness on Iwo Jima went beyond simple statistics of bunkers destroyed or casualties inflicted. The real measure was operational tempo and casualty exchange ratios. Marine divisions that had flame tank support available consistently advanced faster and suffered fewer casualties than units that had to rely on conventional assault methods. The 4th Marine Division, which had priority access to flame tanks during the critical first week, advanced an average of 800 yards per day despite encountering the densest fortifications. The 3rd Marine Division, which had less flame tank support initially, advanced only 400 yards per day in similar terrain. Casualty rates showed similar disparity. Battalions assaulting with flame tank support suffered an average of 15 casualties per 100 yards of advance. Battalions without flame support suffered 35 casualties per 100 yards in equivalent terrain. The mathematics were brutal but unambiguous. Flame tanks saved American lives on a scale that justified every resource devoted to them. General Holland Smith, Commanding General of Fleet Marine Force Pacific, submitted his assessment of flame tank operations to the Joint Chiefs of Staff in April 1945. His report was unequivocal. The flamethrower tank has proven to be the most effective weapon developed for reducing fortified positions in the Pacific. Its impact on casualty rates and operational tempo cannot be overstated. I recommend immediate expansion of flame tank production to support all Marine divisions and request that priority be given to this weapon system in planning for Operation Olympic, the planned invasion of Kyushu. Smith's recommendation was approved. Production of M4A3R3 flame tanks was increased to 200 per month, with plans to eventually equip every Marine tank battalion with a flame tank company. The Army, initially skeptical of flame weapons, requested its own allocation based on Marine Corps success. By August 1945, when the atomic bombs ended the war, over 800 flame tanks had been produced and were in various stages of deployment to the Pacific. These vehicles would never see combat. The Japanese surrender made Operation Downfall unnecessary, sparing both the flame tank crews who would have operated them and the Japanese defenders who would have faced them. The legacy of Iwo Jima's flame tanks extended far beyond the immediate tactical impact. The battle demonstrated that technological innovation, combined with sound doctrine and competent execution, could solve seemingly impossible tactical problems. The Japanese fortifications on Iwo Jima represented the apex of defensive engineering. Every lesson learned from 3 years of Pacific warfare had been incorporated. Every advantage of terrain had been exploited. The defenders were elite troops, well supplied and deeply motivated. By every traditional measure, the position should have been nearly impregnable, requiring months of siege operations and accepting catastrophic casualties. Instead, the island fell in 36 days. Casualties were still severe, over 6,800 Americans killed and 19,000 wounded. But pre-invasion estimates had predicted 40,000 casualties for a campaign lasting 3 months. The difference between prediction and reality was attributable to multiple factors: superior American firepower, excellent combined arms coordination, relentless tactical pressure, and the flamethrower tank. How many lives did the flame tank save? The question is unanswerable with precision, but operational analysis provides estimates. If every bunker destroyed by flame tanks had instead required infantry assault, using average casualty rates for such assaults, approximately 2,000 additional American casualties would have resulted. This figure represents flame tanks' direct impact. The indirect impact through increased operational tempo, improved morale, and psychological degradation of enemy resistance likely saved additional lives but cannot be quantified precisely. What can be stated with certainty is that every Marine who advanced behind a flame tank, watching impregnable bunkers reduced to smoking tombs in seconds, understood that technology had given them an edge that courage alone could never provide. The men who operated the flame tanks paid their own price. The psychological burden of burning other human beings alive, even enemy soldiers, even in service of a just cause, left scars that many carried for life. The mechanical complexity and danger of operating vehicles filled with hundreds of gallons of volatile fuel under combat conditions took a toll on nerves and health. The knowledge that enemy forces specifically targeted flame tanks, that every time you fired you marked yourself for counterattack, required a particular kind of courage. Yet these men volunteered, trained, and fought with their terrible weapons because they understood the calculus. Their willingness to bear the moral weight of flame warfare saved the lives of other Marines. The men walking behind the tanks didn't have to assault bunkers that could be flamed. Infantry companies retained combat effectiveness because they weren't ground down in bunker assaults. The battle was won faster, ending the killing sooner because flame tanks existed. The flamethrower tank represented American industrial civilization at war. It was a product of advanced metallurgy, chemical engineering, mass production, and tactical innovation. It required petroleum products, specialty chemicals, high-pressure gases, precision manufacturing, and trained crews. Only an advanced industrial economy with global logistics capability could field such weapons in meaningful numbers. The Japanese, despite their courage and tactical skill, could not match this technological and industrial capability. They fought with rifles, grenades, and artillery that would have been familiar to soldiers from World War I. They prepared magnificent fortifications using hand tools and explosives. They fought with suicidal bravery and tactical competence, and they lost because industrial might, properly applied, defeats courage. The 8 flame tanks that landed on Iwo Jima on February 19, 1945 were manifestations of American power. The 600 fortifications they destroyed were proof that power deployed. The Japanese soldiers who died in those bunkers learned in their final moments what modern warfare truly meant. Not glory or honour or martial spirit, but mathematics and engineering and overwhelming material superiority. The flamethrower tank turned Iwo Jima's bunkers into graves not through chance or individual heroism, but through systematic application of technology designed specifically to kill efficiently and terribly. That was its purpose. That was its achievement. That was its legacy. The volcanic island where the flame tanks proved themselves is quiet now. The bunkers remain, tourist attractions and historical sites. The black sand beaches where Marines died are peaceful. The volcanic rock that absorbed so much napalm has been reclaimed by vegetation. But the memory remains. The memory of how American engineering created a weapon so terrible that it broke the will of the most fanatical defenders in modern history. The memory of how fire, controlled and directed by men who understood both its power and its horror, turned fortresses into tombs. The memory of how 8 tanks changed the nature of a battle and saved thousands of lives by ending thousands more. That memory endures. That memory defines the flamethrower tank's place in military history. Not as a weapon of glory, but as an instrument of necessary horror. Not as a symbol of martial virtue, but as proof that industrial civilization at war possesses tools that traditional warriors cannot match. The flame tanks of Iwo Jima demonstrated what modern war truly is. Not a contest of courage or skill, but a contest of industrial capacity and technological sophistication. The side with better tools, properly employed, wins. The side without those tools, regardless of courage, loses. On Iwo Jima in 1945, the flamethrower tank was the better tool. The bunkers became graves because technology made them so. and thousands of Marines went home because 8 tanks with flame guns made the difference between tactical stalemate and decisive victory. That is the legacy of the flamethrower tanks of Iwo Jima. Mechanical, efficient, terrible, and ultimately decisive.